I'm going to speak a little bit about our mechanism that we've designed for our Mechanical Systems 2 project. Our project involves moving the 5-pound weight a distance of 30 centimeters and vertically about 2 inches, 50 millimeters is the height that we chose here. Our particular mechanism is driven by a driver dyad located on the far side. That's attached to a slider arm that's got a slot inside of it that is allowed to swing. As this arm swings, it drives a pin that is a cylindrical joint on this bar member on the inside, which has another attached arm member which is allowed to follow and traverse along this pathway that's cut into our barrel on the outer edges. This barrel is ultimately cut to allow for the arm to raise basically from its standing position here as a linear travel over the wall and then fall at the end, dump the weight, and be able to return back to ultimately pick up more weights and continue the cycle. I'm going to go ahead and play the animation so you can see the weight traversing the wall and being dumped, and then we'll speak about some of the graph outputs that we have obtained from this particular mechanism. So as you see, it's a slow linear increase the entire time. It's a fairly consistent torque output as well when we start talking about our graphs in a moment. We have a bit of true interference with the arm to dislodge the weight as it is dumped over the wall, which you'll see here in just a moment. There you go. So ultimately, this mechanism we believe is going to be fairly efficient in moving our weight. We plan on doing slight re-estimations and redesigns and calculations over the next week to tweak our designs, and we'll come out with another video to speak about these graphs that we have. I'm going to head and let the recording play. On our top left, we see our crank position, which this is basically showing our power stroke. It's about 110 degrees total as it sweeps to get the weight from starting position over the wall right as it ultimately dumps the weight on the other side of the wall. The next graph we see is our angular position of our slotted arm, which follows a similar trajectory as the crank does, but varies slightly just because of its curvature and its connected nature. The third graph, we have slider acceleration, which you can see is very, very low until you get to the end when you drop. And during the drop, you receive very high acceleration increase, and that's literally due to it being driven downwards to throw the weight off of the mechanism. On our bottom left, we have slider velocity. I find this graph particularly interesting. In watching the mechanism, I don't understand why we have received some of these outputs, but this particular graph I find to be useful and should hopefully tell a little bit more about why it's being moved in a particular manner. The next graph, we see our torque output for our slotted arm, which when we initially designed the mechanism and were having trouble, this is where we were able to produce a result of torque output. As you can see, it's very sporadic. I believe this is due to the geometric design of the arm itself, but we'll look more into this in the future. And then finally, we have the smooth torque output from our driver dyad that shows a smooth increase in torque from the very beginning to the end. and will help us ultimately plan on what gear ratios we're going to have to adjust our gearbox to achieve. Thank you so much.